Good evening, ladies and gentlemen, and I'm particularly pleased to welcome such a great audience. It's interesting to know what attracts people, isn't it? And I hope that my husband said to me that I'll have to repeat the sex and violence in my subsequent lectures this year as well. That might be more tricky. But first of all, welcome to the lecture. My professorship is sponsored by the Frank Jackson Foundation, and I do want to offer them my thanks for this second year. My series this year is entitled Britain in Troubled Waters, but lest anyone thinks that they're entering the seamy world of economics, global economics, it's not that. It's going to be broadly scientific, concerned with environmental issues and specifically with the world of water. So that's the series as a whole. This lecture, this particular one, is a little different in that I'm going to be talking about the even seamier world of murders and murder inquiries. And I'm going to talk particularly about some cases with which I'm familiar myself. The bodies of murder victims, either whole or in pieces, often finish up in rivers and canals. And for about the last 15 years, I've been working with various UK police forces, including the military police actually, in applying the basic principles, or some basic principles of environmental science to assisting the police in what are really very tragic and gruesome settings. We're looking at where bodies might have gone to, or alternatively come from, if they've been found. And I want to take you really from the details of particular cases to the general principles of tracing bodies. And just to paraphrase a popular TV series, I like to think of the river as a silent witness, because there are clues we can use and evidence that we can gather to establish more about what may have happened or what cannot have happened in particular circumstances, so that we can help the police. Now, this association between murder and rivers happens all the time. People believe, apparently, that rivers and canals are discrete places to dispose of incriminating evidence. And so later on, we have scenes of ambulances and small tents and police tape on riverbanks. Here's a peaceful riverbank in Hertfordshire, where the body of a man in his 40s was found in April this year, an unexplained death. Very peaceful, little bit of police tape there. Here's another one, Rochdale in the north of England, more body parts. The local press went crazy over this one, told lots of tall tales about it, and they turned out to be animal parts. So don't believe everything that's in the press. Here's one much closer to home, in the Thames. This one, in June, it came to court. I will give you a little bit of the details because I want to enrich the science with just a little bit of the gruesomeness, if you'll bear with me. This one involved a retired firefighter and scout leader who bungled an attempt to dispose of the inconvenient body of his, what I would say, inconvenient stun in the Thames at Deptford. And he was spotted by the police whilst trying to offload it over the embankment, but he changed his mind when, unfortunately for him, he realised that the tide was coming in, not going out. And I just have to repeat the conversation as it was reported. It says the defendant was asked by an officer if he knew why he had been stopped, and he replied yes. He was then asked, "What have you got in the car?" And he replied, "A body." Officers uncovered the body, and it was lying on a blood-stained tarpaulin in the boot. And they asked him if anyone else had come to harm, and he said, "No, there's only one body you have to worry about." I mean, you couldn't make it up, really, could you? And he then went on to plead not guilty. But he was jailed for life. Now, I'd like to introduce you to a bit of the science with a very simple case. Again, not far from here, one of mine. A man's body was found on a Saturday morning in the Grand Union Canal at Camden Lock, vertical in the water with just his head poking out above the water surface. And you can see, if I can get this right, this is my symbol for what's recorded here as the scene of the crime. Of course, it's not really the scene of the crime, it's where the body was actually found. And he was just his head sticking up, the top of his head, and his feet resting on an underwater ledge in the canal just here. And I'm sure some of you know this area quite well. Actually, that's a rather strange comment, as I'll come back to in a minute. But I should say, too, that his clothing was undone, and that had led to some speculation about what he might have been doing prior to entering the water. And he'd been seen the previous night in a nightclub, not very far away. Now, many people think, of course, that canal water doesn't move, but actually it does, both with the opening and shutting of the lock gates, and you can see, just if you look carefully, there's a lock gate down here, and every time it rains, there's a little pulse of water moves through the canal as well. So in this case, the water's moving from west to east through down in this direction towards the Thames estuary, but very, very slowly. Now, when I visited the site, it was impossible to measure the flow rate with conventional means because it was just too slow. But what I managed to do was to use some biodegradable dye to measure the velocity. And we've got a picture here, yeah, diagram here. In conjunction with the evidence about the lock gate not having been opened during the night, I was able to identify the starting point of the body. Oh, excuse me. Can't go backwards, it seems. But anyway, I was able to identify the starting point of the body, and it ruled out him having come a long distance. And of course, it didn't answer the question about whether he was pushed or had fallen in or anything of that sort, but it did rule out some possibilities for the police. And just as an aside to this one, I should say that some elements of the research process were quite startling for some of the groups of drug users who were apparently half asleep on the bank of the canal, because first of all the water went bright yellow and then bright blue, and I have a suspicion that they might have had some concerns about what they'd taken. But anyway, right, let's turn to more general matters of murder for a minute. The figure I have is 526 people died in England at the hands of another person in 2013-2014. The rate is actually falling, but there were, again, figure for the same year, 108 known murders in the Metropolitan Police area, but actually none in the square mile, which I think we're in now, so you're probably, at least in the early stages of your return journey, reasonably safe. I don't know how many of those ended up in rivers, but a significant proportion, certainly. And this map of homicides for the same year, contrary to what might be purveyed on TV serials in Morse and Lewis, shows the distribution with that rather reassuring gap around Oxford, you see, where there. And I think also, I don't know where you think DC Barnaby operates, but I've always thought it was Somerset, but apparently that's Oxfordshire as well, so that's wrong on that count as well. And again, if you watch Agatha Christie's very charming Miss Marple, which I'm sure must be somewhere in the southwest, there's not much going on there in reality either. Apparently, the murder capital of the UK is Bedfordshire in terms of murders per head of the population, at least in recent years. But there is, of course, this large cluster around London, which, of course, is cause for concern, and quite a few in the northwest as well. To get a fuller picture about bodies in rivers, we'd have to add in suicides as well, but I'll say a little bit more about that in a minute. Now, I will make one point here about the lecture. Every murder case is clearly a tragedy, but the science of the investigations, to me, is absolutely fascinating, and it has a tendency to make me, and perhaps you too, smile. Now, you'll need to forgive my enthusiasm for a macabre subject, and also perhaps I'll forgive you for an occasional chuckle, because some of the circumstances are rather curious. The work, this kind of work, arose for me in a rather serendipitous way. I used to undertake, and still do actually occasionally, undertake hydrological inquiries for public inquiries when people are proposing to build something. And I was involved in a sand and gravel inquiry in Warwickshire, and an off-duty detective was there. I assume somebody was planning to dig up somewhere close to his house, and he was there to make his opinion felt. And he suddenly asked me, just at the end of the day, whether I'd had any experience of, or whether I'd be able to look at the case of a body that was been found floating in the Thames, very Dickensian, if those of you who know the 19th century literature. But I had actually, and this sounds rather strange as well, I had some experience of teaching undergraduate students about the flow dynamics of rivers by floating a few of them, alive, I should say, down the river, in the River Severn, in wetsuits whilst on a field trip. And so I used to tell them, hold hands, and when I say go, let go, and the rest of us will watch what happens. And we used to watch them float off down the river and see what was happening to them. So I told him that I'd never tried tracing dead bodies, but I'd be willing to have a shot, and that I liked a challenge, and it grew from there. And I've now advised on about more than 20 fairly significant cases since then. Now, as a general principle, there are various things involved in undertaking an inquiry, from understanding what you're being asked to do through to satisfying the client that everything's been done and presenting the case possibly in court as an expert witness. I also want to share with you some of the instructions that I get, and this is an example of an early one. And if you look at what it says in the facts, so this is going back ancient technology here, it says, radar body found in the River Thames, when can you start, how long it would take, what will it cost, and do you need to know the weight? So there actually aren't, it doesn't tell me what I'm supposed to be doing. It just says, what will it cost? And when can you start? So although there is a question, there's clearly a question. A body had been found in the river, and they basically wanted to know, in that case, where it had, that was a case of where it had come from. Now, some cases, of course, are not murders. As I mentioned earlier, some are clearly suicides, and some are the loss of children or non-swimmers in exceptional circumstances. This one here, which we'll take a first look at, is again somewhere that may be broadly familiar to you. This is again on the Thames at around about Eton. This is Boveney Lock here. This is the Thames running down into London, and the body there was found floating in the river by a rowing team, actually. This is a situation where the body was lost, and the police were keen to know where to start the search. I beg your pardon, I think I've got that the wrong way round. A body was found, in this case. The police wanted to know where to start to look for where they'd gone into the river. Now, underwater search teams are expensive to deploy. Searching rivers in flood is difficult, and it's very dangerous. And anything that can be done to work out the maximum distance that a body or parts of a body or a body in a suitcase, as we'll come to in a minute, might have travelled in a specific time period is very welcome. So the more typical inquiry actually is a body's been found and the police need an indication of where it's come from. So in that case, speed is less of an issue. Speed of working is less of an issue. Although, of course, in the interim, there might be murderers at large. So there is always some element of pressure there. Now, some of the evidence that we need, as we see on the right-hand side of the screen here, is broadly scientific. So here we've got recorded flow data or river depths, which are part of the raw material that I need to be able to establish the velocity of the water at the time and place of the incident. So this is some data forwarded on to me by the Environment Agency as part of their routine monitoring. But the problem is that it's often unusual to find the right data for the right place and the right time. Unfortunately, murderers don't choose their deposition sites in line with the Environment Agency's network of monitoring. So you have to reconstruct the flows using other kinds of methods. So it could be from the rainfall data or from flow data from some other location close by. So I'm modelling the flow then, rather than actually observing it or having an observation of it. And I should say it's very far from being an exact science, because we often can't replicate the thing experimentally. I can't reconstruct what was going on in terms of the flow of a river just like that. What I have to do is to get the best possible information and use some judgment. So sometimes it could be partial information. And here's an example of witness statements. I'm not going to read them all out, but this is the kind of things that people will say. So the first one refers, I think, was somebody saying they saw a log and they floating, and there was a description of where it was. It turned out to be a body. And then there's a description from one of the police underwater search team talking about the bed of the river, scaffolding poles and car parts. It's, in my experience, it's often shopping trolleys, that's referred to there. But occasionally it's fridges. Why is it? How does somebody manage to throw a fridge into a river? Extraordinary. But this is important information. And then the lower one there is one of the lock keepers talking about the way he was managing the water over the lock at Boveney Lock in the case we just saw. So I'm using that kind of information to support the hydrological evidence that I may be able to collect from other places. Now, then I've got to prepare the case, and as it says here, it may well end up in Crown Court. Now, if I was going to explain, build a model of exactly what happens to a body in a river, I'm going to divide it into 4 phases, really. It's what happens when it enters the river, and then what happens when it decays, and how does it get into the flow and move, and how does it land somewhere if it's actually found on the bed of the river or on the river bank or something like that. So I'm going to use, as a first example, I'm going to look at this issue about what happens when a body enters the river. And this is a case in Wolverhampton. Is anybody here from Wolverhampton? No? Ooh, somebody is. Oh, welcome, Peter. I won't be as rude as I might have been then about Wolverhampton. What happened in this particular case was a number of telephone calls were made to the police between January and March 2008 about body parts that people said they'd seen in the Birmingham Mainline Canal between Lock 6 and 7. And then the police sent somebody out, but they didn't find anything. And you can see here the nature of the environment, the scene of the crime there, the kind of setting here. It looks rather idyllic, but there's the little tent there. And now here you can see the canal drained down. But the point is that after these non-sightings, or sightings were recorded but nothing was found, the next day in the afternoon, a dog walker found or saw a very decomposed torso on a mud bank at the side of the canal. And her attention was actually attracted to it because some children were throwing stones at it, and she thought it was a dead sheep. But it turned out to be the rib cage and the top part of a human body. Now, I should advise you here to look away if you don't want to see what was discovered afterwards. So this is, you can just about see in the image here, there's something there. Now, the police drained the canal down, and they don't do that lightly because it's difficult, it's engineering, it causes engineering problems, it stops the boats going up and down and so on. But what they had to do then was to search. And if you think the police don't earn their money, I can assure you in this kind of setting they do. So they were raking through the mud on the bed of this canal, and it got worse and worse and worse. And eventually they found some pieces. In fact, what they found was 11 body parts on the canal bed, the entire body except the left femur and the head. And it was a 32-year-old man, and they later revealed that he was a small-time cannabis dealer, and I'm going to call him Mr. DD for now. But Mr. DD was last sighted in Wolverhampton about 4 months before, and there was some insect evidence suggesting that the body parts had not been exposed for very long to the air, but that was kind of inconclusive. And we'll come back to insect evidence in a minute. But the main problem, and one of the main problems, was the lack of a head. There was no head. So they had difficulty in identifying who it was initially. And what they wanted to know was if there ever had been a head there, or had there ever been a head in that spot, and was there some mechanism by which it could have been washed away but left the other parts behind. And you'll think, if you think about it, a head is a kind of spherical and it sticks up above the river, the canal bed, and therefore potentially might have been washed away. At least that's what the police thought. So what I did was, my lab technician, who was a genius, made 2 model heads, and I'm showing you here what we did with them. These are much too large for the picture, but he made 2 model heads, slightly different in weight, and appropriate for the size and weight of what was thought to be a slight person. They actually thought from the bones that the person was 5'7" and about 10 stone, so quite a small person. And we made up 2 appropriate heads. The head had been severed at just above the shoulders, and the lighter one was kind of consistent with a head with a bit of decay inside and some gas. And we connected them with some very fine filaments there, and we experimented with opening and shutting the lock gates. So here's some of the lock gates here. We sent sort of pulses of water down to see whether we could actually move these heads when they were in the river. And that enabled us to suggest what kind of velocities would be required to move the head. And I won't go through all the details, but in fact the velocities were not high enough. So what we said to the police was, if all the body parts had been thrown in at the same time, they would all be still there. And they weren't all still there. The head was not there. So this enabled the police to switch their search. So instead of trying to drain down the rest of the canal, which would have been incredibly expensive and technically very difficult, they switched their search, and actually they found the head in a plastic bag in a drain a little way away. Deeply unpleasant, of course. We also, as part of this, we looked at whether there had been any unusual activity in relation to the lock gates, and this just shows you the cumulative number of times, how many times were the lock gates opened and shut over that 4-month period. And you can see there's a general, the gradient of this line is going up as we go along with time along the bottom there. So it's actually getting more and more use as you approach the summer. That's what you would expect. But there's nothing unusual in there. So there was no reason to think that somebody had opened all the gates and swept all of these things or the head away. So the police were able to look elsewhere. Now, in fact, there was a bit more work done on this by, this is me modelling flows, likely flows in the river. I won't bother you too much with this because we'll come back to some diagrams like this a bit later. But marks on the bones showed that the rest of the body had been cut up with various types of saws. And just to fill you in on the rest of the gruesome detail, Mr. D.D. had been reported missing by his girlfriend, and a few weeks later she'd moved into a house quite close to the canal with his friend, and I recall that the friend worked in a sawmill. Now you can draw your own conclusions from that, and the court did too. But the murder was thought to be committed because Mr. D.D. had sold the murderer a laptop computer that didn't meet his expectations. So not too clever, in fact. Now, I do want to add, I'm going to put in a little extra story here because I think I'm doing okay for time. Some murderers, that murderer was not very clever. Some murderers are very clever. And perhaps sometimes not quite clever enough. But the story I will add in here, which is not on the transcript, which you can pick up afterwards, was the police approached me about somebody who was thought to have disposed of a body in the River Dee on the Welsh border. And we went to have a look. It's a really fast-flowing river, the River Dee, and the investigation was quite difficult. My lab technician and I were kind of swirling around on an inflatable boat trying to measure the velocity of the water. And it's deep and very, very fast. And anyway, the police, and we worked out that if a body had gone in there, it probably could have been miles away. But the interesting part of the story was that the police had somebody in mind for this. And it was somebody whose number was found on the victim's mobile phone. So her phone was found in her flat after her some friends reported that she hadn't showed up for lunch with them. And so they looked at the mobile phone, broke into the flat, found the mobile phone, and the last number she had dialed was this man. There is some sex involved, which I won't bore you with. But anyway, they went round to see him, and they asked him where he had been. And in order to check where he had been, they took his credit card off him, because you can tell where somebody's been from the credit card records. And what they established was that he had bought some gaffer tape, a shovel, some rope and some plastic bags, and a very large floral suitcase. So that obviously this prompted some thoughts as to what might have happened to the victim. So they went back to see him, and they said, "Where's all this stuff you bought? The shovel, the gaffer tape, the bits, the rope, the suitcase, and so on." And he said, "Here it is." And it was still there, or it was there in his house. And the police, I can imagine the police scratching their heads and thinking, that's a bit odd. Anyway, but they didn't give up. So they went particularly for this floral suitcase, which was very unusual and a sort of big suitcase. And they went back to the shop and found the shop that sold them. And what did they discover was that this man had subsequently, after the police had taken his credit card, he'd realised that they would be able to track his purchases. So he went back with cash in hand and bought all the same items again. But he was caught on the CCTV, so they knew he'd bought 2 lots. And in fact, the body was not in the river. They found it buried in some adjacent woodland. So some criminals are actually quite clever, but not all. Okay, now, let's just look at the body entering the water. And we have to understand a little bit about what happens when a body enters the water. Now here, you can see here, this is I'm very grateful to the Institution of Environmental Sciences for drawing me these diagrams, but here you can see a body entering the water, and it's going to go down through the depth of the water, which can be any kind of depth. Bubbles are going to come off it, it's going to sink to the bottom, at least initially, and it's going to end up a little bit further along the river from when it went in, because of the shape and the clothing and the density of the body. So it's going to end up probably on the bed of the stream. There's the obligatory shopping trolley, of course. And then it's going to start to decay. And the rate of decay of the body is going to be affected by the temperature and the size of the body, and it's going to generate a volume of gas in the body, now particularly in the torso. Not anywhere else in particular, but in the main chest or abdominal cavity of the body, because those are where there are voids. But at least initially it's going to sink to the bottom of the stream. And the rate at which that decay takes place is quite variable, but this is the sort of time we're talking about. So first of all, what we get is something called washerwoman's fingers after a few hours in cold water. These are timescales typical for the UK. If we were in the tropics or the sea, it would be much faster. But we get some decay within a few days. It starts to look a bit older within about a week, and then within a couple of weeks it's starting to get seriously deteriorated, and then we hit this bloat, what the analysts call bloat, where we've got gas formation in the abdomen and thorax, and that's a variable amount of time. And then finally, after some weeks, months, depends on the temperature, the thing will become a skeleton, will start to fall apart. So this is a bit grisly, I know, but you have to understand that, because that's what's going to influence what happens to the body when it goes into the river. Now, I want to look at an example where bloat and rising of this body was fairly critical. And this is another canal example. This is Operation Sanderling, again in a northwest Birmingham canal. You can read into this what you like, Peter, if you live in northwest Birmingham. But if I can just tell you the details again, this is more recently. This is actually the most recent case I've been involved in, but in May last year, a waterlogged suitcase was found by some staff from the Canal and Rivers Trust, who are excellent people who maintain rivers and canals. And it was caught, the suitcase was caught alongside some reeds at the side of the canal, not far from the town centre, actually. So this is here's some lock gates, and this is what the canal looks like. There's a towpath and so on. And this is, on the bottom left here, this is the suitcase. The suitcase here is minus its contents because they pulled these trusty stalwarts in a maintenance barge, found this suitcase, and they tried to snag it and pull it onto the boat, but they couldn't lift it. It was very heavy and it smelt rather unpleasant. So they towed it behind the boat back to the maintenance department, and then somebody lifted it out of the water. And when they opened it up, they found what was described as a torso with a left leg and part of the right leg inside, and it was bulging because it had started to fill with gas. And you can see here that it actually is further open here, but when they found it, it was partly open. The zip was partly pulled apart, and it had been weighted down with some pieces of concrete. So inside the case, obviously. So here we've not got a body. Again, we've got some body parts in a case. I have to say, my husband said that's not likely to be suicide then, is it? So the police started searching the mainline canal. The body was found down here, somewhere. Yeah, down here. They started searching the mainline canal, right up here and the other way as well. And they found up here, they found a second suitcase with the missing bits in it, again wrapped in plastic bags and weighted down with bits of rubble. Now, any of you that have ever been on a narrowboat holiday will know that canal networks are really complicated. And the Birmingham canals, the usual thing is there are more canals in Birmingham than in Venice, yes. So I'm not sure it's true, actually, but it's often quoted. So there are lots of channels and pipes and reservoirs and locks and sluices and overflows and so on, trying to maintain the river level so that boats can go along it. Now, in historic times, this was probably, and we have to go back quite a while, this was probably part of a natural river network. So it has big loops in it, and they're not very easy to see on this image, but there are various loops, I think there's one there, that have been cut off by the canal network. But it makes it, again, very difficult to model the amount of water, because some of it's going around these old loops and some of it's going straight down the river. But in this particular case, there are various reservoirs that top the water level up. And so the water actually more or less moves down in this direction towards the city centre in Birmingham. New Street's down here somewhere. This particular diagram is showing you some witness statements. People who said at one time or another they'd seen a suitcase floating in the water. And taking the timings of those, and witness statements are not always accurate, by the way, and some people like to get in on things. So if the press report that there's been a suitcase, hundreds of people suddenly report that they've seen it, which may or may not be the case. But in this particular instance, I was able to use the witness statements from the point at which the body was found down here and the date of that. And these are dates going earlier in time as we go to the left, and we can track back upstream. And when we get up here, this was somebody who said they'd been on a narrow boat on the 4th of May that year, and they'd had to pull a floating suitcase away from their boat to get through the lock. But they hadn't thought any more about it. They just thought somebody's thrown a suitcase in the lock. So this took us back upstream, and it took us to a point where, in fact, the police had found the second suitcase with the rest of the body parts in it. So what it looks like is that there's a chance, at least, that the two suitcases were thrown into the river at the canal at the same time, and then one had floated away. So we have to start thinking, well, why has one floated away and the other not? And the answer lies, of course, that in one was the torso with the gas-filled void, which had probably brought the suitcase to the surface, and then it had moved along the canal. And it had moved along the canal broadly in this direction. The second suitcase was found here, actually, here in the water. But the the first one had gone down in this direction over the course of a couple of weeks. And I looked at the flows. Well, I couldn't actually measure the flow of water because the instrumentation on the canal had broken. That's a common thing. So I started looking at rainfall data. I was looking for pulses of water that might have moved through the canal network. And I couldn't get that data, but I got rainfall data. I got, I think I've missed one here. Oh, well, lost one. Anyway, and I looked at wind speed. Now, wind speed, in the case of a floating suitcase, the wind actually starts to become significant. And this diagram is a bit complicated, I'm afraid, because what the Met Office record is the bearing. This is the direction from which the wind is coming. So what we have here is 360 degrees, is the wind coming from the north. And down here, this is also wind coming from the north, whereas this is wind coming from the south. Okay, and in between west and east. So the orange line is the speed of the wind. But by looking at this, you can tell which way the wind was blowing on particular days, obviously. Actually, the other thing we might note is it was pretty warm. So we've got daily averages. This was May, and it was anything up to 12, 13, 14. That's pretty warm, actually, for May. So what do we think? What can we reconstruct from this? Well, the most likely scenario is that somebody threw both suitcases in the river, in the canal at the same point. The first suitcase filled with water very quickly because it was partly open, sank to the bottom right by the point of entry. The other one, the second suitcase, was actually zipped up. It probably maintained its integrity a little while. It just moved a few metres down the canal with the flow. But then over the course of the next 7 to 10 days, it was warm. The body in the first suitcase was decomposing. It filled up with gas. Really nice. Pushed all the water out, swelled up, and then started to float because it was expelling water from the suitcase. And it floated to the surface on about the 2nd of May, and when the winds were predominantly from the north, and they kind of kept it where it was. But as the wind direction shifted over the next few days, and with the predominant slow flow and a few flood events, rainfall events, it pushed the suitcase southwest into the centre of Birmingham, where the police found it some days later. Now, again, I'll give you just a little bit of richness with this because I really have to tell you the story of what happened here. This person, I'm going to call him Mr. M. Okay, but the person who was accused of the murder was I'm going to call L, and he was quite an interesting man. L. He was a former drug addict, and he had actually worked for Jamie Oliver and at Blenheim Palace as well at one time. So I don't know how that worked, but he and his partner, who's Miss B, she was 35, he was 34. They were found to have murdered their housemate, Mr. M, at their home in Smethwick. And then L stole his benefit payments afterwards as well by using a benefit card, apparently. And what happened was when they were arrested, this chap L, he said that Mr. M had attacked him because he told him to leave the house, and that he died after he'd fallen from the floor. He'd punched him and he fell to the floor, and unfortunately he died. So he admitted that he killed him, but he said it was an accident. And he said then he'd taken the foolish decision to cut the body up and dump it in the nearby canal. And he told the court, we were previously a good team. We worked together. I had a lot of respect for him. I looked up to him. And he also said he had an anxiety disorder and he hadn't thought very clearly about what he was doing. Now, of course, QCs are very clever people and they are inclined to be quite sharp. And I love the wording that was used by the QC. He said to him, "You had a lot of respect for a man you murdered and then tossed his body in a canal. You couldn't have severed that man's head with his own saw if you had an atom of respect for him. You're not someone crippled by anxiety at all. You are a perfectly composed, manipulative man who tried to deceive the jury into believing your account. You destroyed Mr. M's body not out of panic, but out of necessity. You cut him apart so that we would be deprived of knowing how he had met his death. So he admitted it. But the girlfriend is interesting, Miss B. She said, I'm 100% innocent. But she agreed that she'd sat on the bed whilst L had cut the body up and tried to burn it. And then she'd helped him take it to the canal. And she said she was frightened of him, but unfortunately, her word, she loved him. She told him in a jail letter, and the wording here is really extraordinary. She told the accused murderer, you're a good man, I love the bones off you. And she knew what he'd done. And the QC pointed out that a body was chopped up in her house, which needed cleaning, carpets burning, clothes being disposed of, with the place ending up in such a mess that a shoulder joint was left lying on the carpet after the rest of the body was dumped in the canal. And Miss B maintained that she never saw any of this. To which the QC responded, you don't see very much or hear very much, do you? And she replied, I wouldn't want to hear or see anything like that. Now, I'm not going to go through all of this, but I do want to give you one final comment from the QC. And he said, the only reason you stayed in that room was because you were helping. It took two of you to put this person in that suitcase and clean up the mess that made. And Miss B said, no, I didn't. And the QC then said, if Miss B's account was true, there was no way she would have slept that night in the room where Mr. B was dismembered. And Miss B said, I didn't sleep. And I suppose perhaps we can take some comfort from that. Now, there's the canal. I just want to show you this little bit. If you just watch the top right-hand corner, this is CCTV footage. There you can see the two of them with the suitcase heading for the canal. And in a minute, you'll see them coming back. And if your eyes are really sharp, you'll see them coming back without the two suitcases. So anyway, he got life. I can't remember what she got. But it was a nasty case. Now, of course, my evidence is not the only scientific evidence that's used. All sorts of evidence is used. Here's some University of Warwick academics. They, in this particular case, analysed the breakages in the bones and identified the saw that was used, which is on the right-hand side there. Other cases use things like diatoms that get caught up in the clothing of somebody that's thrown in the river. And you can see here that diatoms in water come in different forms. We've got here freshwater ones and brackish or saline water ones from the Severn Estuary. So by analysing what's caught up in the clothes, pathologists can work out whether the body has, for example, been in salt water in an estuary or has been only in the fresh water. Similarly, this is pollen. Many of you will know that pollen grains are very easy to identify, many of them, and again can identify whether a body was in perhaps a rural setting surrounded by, say, grass grains, wheat or something like that, or in an area where the pollen is diverse, very diverse, where there are maybe exotic garden plants. Okay, so that's another possibility. Look away if you don't like this. Insect infestation. I'm just looking to see who has looked away. Nobody, actually. Insect infestation can indicate, this is a piece of human body, can identify whether or the length of time that a body has been exposed to the air. And occasionally, you get other bits of evidence. I will mention later, in a few minutes, a case where a body was impaled with a piece of wood that turned out to be a branch from an exotic tree, and the police managed to find the right garden where it had come from. So, let's move on. Let's take another example. This is, again, relatively straightforward example, but interesting, I think. Operation Celt. This was a case that occurred in the River Ouse at York. And what happened here was a woman, I've called her Miss LD, but she was quite slight. She was 36 years old, and she was last seen in June 2008 here, allegedly, just here. And the River Ouse flows south like this. We're on the northern edges of York, and it then flows on away down and out to sea. This witness is a young chap who said that she had slipped into the water accidentally about 7 o'clock while she was very drunk, and in fact she was almost comatose. And what happened, he said, was that they'd bought some vodka, and they'd sat just here under a tree to drink it, the whole bottle, actually 2 bottles I think it was. And her erstwhile drinking partner described seeing her slide into the water. And then he said he failed, he tried to grasp her coat and pull her out, but he couldn't, so he gave up and went home. He didn't actually go home. He got a train to Southampton, which is quite a long way from York, isn't it? So he was eventually tracked down, and they identified this spot because, of course, initially the police didn't know where she was. They just knew she was missing. And they conducted some searches, but she was never found. And 2 years later, in 2010, I was asked to say something about the circumstances of the river at the time and any likely locations where the body might be. And so, again, I'm not going to go through the details of the science. I could, but what I did was, based on measurements you can take of the flow and certain assumptions about, that you can make, and knowing something about the channel dimensions and the roughness of the channel and the slope of the channel, I managed to establish the likely velocities at this particular point. Now, the River Ouse is a slow, turbid, very cloudy, wide river. It's a pretty powerful river. I say they're slow because when it goes into flood conditions, it really hammers through. And it's a very powerful river. And what actually happened in this instance was that the body was lost, and you can see here the body was lost. It's disappeared off the bottom of the screen, but July 2008 here. And here's this particular flood peak here. And then some of you will remember serious flooding in York. It was on the television, and there were some major events here, and another one here. So the body was lost. If we look at the detail of the day the body was lost, or she was last seen, you can see the flood waters rising. And although I can't say whether or not her drinking partner pushed her into the water or not, you can certainly see that if she had been nearly comatose and had been sitting under a tree right on the edge of the water, over the space of a few hours, the water level would have risen around her and quite possibly just swept her away. And it would have got to be moving very quickly. And so it is feasible that he hadn't actually pushed her in. It was as he had described. That's certainly a possible scenario. I'm not going to go through all this. This is a way where you might calculate it, but there's a sort of iteration involved, so let's not worry too much with that. What happens when the body gets up into the flow? Okay, now, what actually happens, and here's our erstwhile body again, is that river velocities, particularly in flood conditions, they move relatively slowly near the bed, and they move much faster towards the top. The peak velocity is just below the surface, actually. And what happens with this is that two things. First of all, you've got gas in the body, and secondly, this is like an aeroplane lift, and as the water flows over the body, it tends to draw it up into the flow. And therefore, at this point, it rises up and goes along with the velocity of the water. So the thing that would dictate how far it got would be whether there were any obstacles in the way. And we can look at that in a minute. Grounding. What happens to it at the end of the pathway? In this particular case, it could be some time later, or it depends where the body's been in the interim, but we've got a body, perhaps I've described it here as losing its integrity. The gas has come out, it's rotted through, it falls to the bed, or it could be trapped behind an obstacle, or it could be trapped in sediment, or along the side of the river, or in a vortex at the side of the water, at the side of the river. Now, if it's the water's very turbulent, or it's saline, or it's very cold, the water is more denser, and the body is going to float more easily. In this particular case, the body was still found in fresh water, but 7 or 8 miles below York. So we've got quite a complex modelling job here to work out where the body might go in this particular instance and where it might be redeposited. Now, let's just take a short example of this. This is a case, an unusual case. This was a cold case, if you know what that is, a case from many years ago that I was asked to investigate quite recently. And this was a case of a child, a little girl actually, who went missing from an army base. And the army base is here. And you can see here various river channels. This is the river Lipper, goes off down here in this direction. And the story of this is of course, very, very sad. This is a child that went on her 2nd or 3rd birthday, actually. She went with her mum and her auntie to the NAFI, the supermarket store, where they were going to buy some stuff because it was just before Christmas. So it was dark, evening. They went early afternoon. The mother was paying for the stuff at the checkout. She looked round, the child had gone. So they started hunting in a panic. The child was never seen again. Now, it was Christmas time. She was wearing winter clothing, outdoor winter clothing, Wellingtons actually. And the back doors of the NAFI shop were probably open because they were bringing in tons of supplies for all these soldiers that have to have Marmite and stuff for Christmas, you know, English stuff. So they were bringing in all this stuff. The back doors were probably open. Remember, I'm looking at this nearly 30 years later. So the back doors were probably open. There was a car park, and there's this river almost immediately behind, this river Lipper. And what happened, according to the records, was that they started a search. Initially, they looked in the car park, and then they couldn't find her. And then I kind of have this image in my head that there was a panic, and lots of people started being brought in. And I think there may have been a demarcation dispute between the military police and the German authorities. And the net effect of this was nobody really searched properly in the river for probably more than 24 hours. Now, I managed, but nevertheless, one of the hypotheses was that the child fell into the water and was swept away and drowned. And the case was reopened several times subsequently, and searches were made, right down as far as here, where you see there's some gravel pits, lakes and water bodies here. And you can see in this particular image that the river comes like this, and then now it comes round here and it goes round the side of the lake, round here and off on the left of the image there. When they searched in 1981, nothing was found. Now, I managed, using fragmentary German hydrological records, to reconstruct the flow conditions. And my measurement, and some measurements that I made in 2010 actually, and the river regime again was very complicated. This is lots of springs and urban flows and so on, but this is an area where at the time the child was missing, I think there was about a 10-year flood whamming down through this river. And this is a river that over many years, from Roman times onwards, has been straightened and then narrowed and had engineering works. The water really rushes through this section. Now, in fact, 2 or 3 years before I did my investigation, somebody had actually done some engineering works to try and stop this flow. They tried to recreate a more natural river. So there've been a lot of changes, and that's what I want to focus on really, because I estimated the velocity in November 1981 could have taken the child's body several kilometres down easily, okay, in 24 hours. So it's highly likely that if the child was in the river, dead, drowned, the turbulence and so on in this straitened river would have just swept her away and probably deposited her in the lake. So I turned my attention to the lake. And what's interesting, if we look at this lake, these are gravel pits. And this is the position in 2009. It's on Google Earth, but I've coloured it in so you can see. This is the shape of the lakes in 2009. But if we go back in time, using aerial photography and so on, we see that in 1979, the lakes were only like that, very small. And here they are in 1982, so the child was lost in 1981, if you remember. The point is that the point at which this river enters the lakes varies hugely over time. So here's two more, 1985 and 1986. The point is that when this case was reopened, if, as indeed they did look in the lake, they would have been looking in the wrong place because the point at which the channel enters the lake had moved by several kilometres. And they were not aware of this when they were searching. So they were searching where the river entered the lake now, not where it had entered in 1981. Nothing stays the same. So I can't solve that mystery. The child's body has never been found, and in fact another hypothesis is that the child was kidnapped by her estranged father and would now be a woman in her mid-30s. The case is still open, I should say. I inquired about it last week. That's another example. Now I want to give you one last example of where I really tried to bring all my work together. And this is a case that I did in 2002 in the River Bure, which is in Norfolk, upstream of Great Yarmouth. Do we have anybody here from Great Yarmouth? No. Oh, we have. I won't say it. Just think it, the rest of you, okay? Yes. I was once there, when I was there, I tried to find a shop selling books. I ran out of reading material. Right, so the story with this one is that so here's the River Bure in Norfolk, and here's Great Yarmouth down here, and the River Bure is here. It's got this great big loop, goes on up here. This is the Norfolk Broads. Here's one of the Broads. And a body was found here. And the issue is that the body was found on a Sunday morning high up on the riverbank, on the mud. And this is the one where the body was impaled on the branch of a tree. It was a woman. She was a young Somalian asylum seeker, and she had left her work at a supermarket the previous evening, and she'd been dropped back at home by her husband while he went to fetch their child and a takeaway, apparently. And then when he came back, he said she'd gone. He thought she'd gone for a walk. He went to bed. The next morning, she was still gone, but by that time, later in the morning, somebody had found the body. And the police wanted to know, how did this body get here? Was it dropped up here somewhere and had come down, or was it pushed in down here somewhere and had arrived back up here? Now, it transpired when I started to look at this that very night had been the highest tide of the year, the spring high tide. It was a very high tide. I got the data from the Coast Guard Service and the Environment Agency and national tide tables, and I was able to reconstruct the water level at different points in the river, including the point at which the body was found, the so-called scene of the crime. So what we have in this particular situation is a wave of water, a tidal bore, if you like, goes up the river when it's a high tide, and you've seen pictures of the Severn bore, I'm sure. Goes up the river. And that water is partly saline, so it gives extra buoyancy, of course. It does dilute upstream. But the body might have come downstream, because obviously that tide then goes out. And I couldn't actually, with the data I had, I couldn't calculate the direction of movement because there wasn't enough information. I could calculate the level, but I couldn't calculate the direction of movement. So this is, you can see this is me working out the tidal cycle, reconstructing the tidal cycle for the point at which the body was found. Okay, now, so what we had to do, and this was the really exciting bit, we had to wait till the autumn high tide, when there was a similar, not quite as high tide, but similar, and we were able to conduct an experiment with dummies in the river. And it really was exciting. We had video cameras and a helicopter and the river closed to traffic and everything. So we put 2 dummies, this is me constructing the time of the peak high tide from such data as I had as well. So, as I said before, you never got the right data for exactly the spot at which you need it, so you have to reconstruct it, and there's a bit of maths associated with that. Not too difficult, actually. And here it is again. So this is reconstructing levels and time at different places. Okay, and this is the salinity profile. You can see as we come from upstream of Great Yarmouth over here. As we come upstream from Great Yarmouth over here, it's saline in a tidal cycle, and it's fresh water up here. So this water here is very, very buoyant. And remember, the body had a piece of wood impaled in it as well. So we conducted some experiments, and
no problem about that. I've done that years.
That's me looking suitably proprietorial. You can see this is body moving quite fast in this tidal cycle. And we had 2 dummies tracking up, released at different times in different places, and they went upstream.
58.47 for the 6th marker post.
58.47.
And you can see that the body's moved right out into the middle of the flow in that particular instance. Now, using that information, on the second run, the next day, also high tide, we managed to reconstruct the pattern exactly. And we were able to establish that the body had gone into the river here and had gone upstream right up here and then back down again and grounded here. So we managed to do it exactly. And from that data, I gave the police a time of release and a place of release in Great Yarmouth. And fortunately, the police had actually, and remember now 6 months has gone past because of the tidal cycles, the police had archived some CCTV footage from a doctor's car park, a waiting room car park. But they hadn't analysed it all because they'd got lots of this stuff. They'd archived all CCTV footage from all over, everywhere actually. But they managed to analyse it. And I gave them the time window, a 10-minute time window, and I said, look at this 10 minutes here. And they looked at the CCTV footage and they saw a car go down to the river in the window I'd given them. And after the CCTV footage was cleaned up, they could read the number plate. And I can tell you now, there's my analysis. I won't bore you with the timing, but it was the husband that did it. Thank you.